Kia ora. Welcome to this PhET Rates and Reactions simulation. So the first thing you do is you click on the rate experiments. Next you look on the right hand side and we have 100 of each of the reactants. So you just type that in and notice then when we change the temperature, the average kinetic energy increases. So we have some molecules with greater energy than this and some molecules with lower energy than this. But notice that the average kinetic energy is more than the energy needed to overcome the activation energy. Then we're going to have a strip graph, and we're just going to change the scale so that we show the 100 up there because we're starting off with 100. When we begin the experiment, notice here are our particles, and you can see that we are forming some of the C and the AB. Notice how fast they are moving and the number of collisions. If you have a look here, and I'll pause it at 100, you can see the number of particles. We can change to the bar graph so you can see that as well. And notice that it's more or less staying constant now. So if I go back to the strip graph, you'll see we started off with 100. I'm going to just show that 100 over there. It's dropped and it's more or less staying constant. So at 200, have a look at those figures over there, and we'll leave it till about 300. But notice that it has stayed more or less the same. The reaction is finished. And what we'll do now is we'll pause the video so you can see those figures over there. Right, we're going to now try this again. Notice the speed that those worked at, but now we're going to try it again, but we're going to make it very hot. So most of the molecules now will have sufficient energy to overcome the activation energy. So we're going to have this 100 again. We're going to put in the strip graph. We're going to show this at 100, and now we're going to begin the experiment. Notice they are moving more quickly, and it has dropped very suddenly, so it doesn't even show that. And notice that it is more or less evened out at round about 100. At round about 25. So it's dropped more suddenly. It couldn't even pick up those from 100 to down there. And now it has finished. Let's now look at what happens if we have a very cold reaction. So we're going to start this all, reset it, make this 100. And we're leaving it at cold. We're going to show the strip graph. And now we're going to begin the experiment. Notice they're moving more slowly, these particles over here. And what I didn't do was show the correct scale. So here we've got the 100, and notice it's a very slow reaction because very few particles have enough energy when they collide to overcome this activation energy in order to form the product. So we say there's a lower proportion of those collisions because they're still colliding a fair amount, but the lower proportion of those collisions will have sufficient energy to overcome the activation energy. So it's a much slower rate of reaction. So have fun exploring the simulation. Goodbye.